Welcome to the Wolfpack Wellness Research web series. I am your host, Dr. Susie Goodell. This series is a collaboration between the University Wellness Advisory Committee, the NC State Libraries, and NC State Wellness and Recreation. We aim to discuss the wellness research happening across NC State's campus. For those of you who are joining us live via Zoom, you can submit your questions to our speaker in the chat function, and we'll have a Q&A time at the end of the show. And today's guest is my colleague and friend and neighbor, Dr. Carly Arndt. Dr. Arndt is an assistant professor and director of the Trace Metal Laboratory in the Department of Marine, Earth, and Atmospheric Sciences and an affiliate with the Southeast Climate Adaptation Science Center at NC State University. Her work focuses on traditional and novel hydrochemistry applications to better understand hydrochemical responses to climate in polar, fluvial, did I say that right? Fluvial in coastal settings with a focus on local ecosystems and communities. So thank you for joining us today, Carly. I would love to just first hear a little bit about yourself and your research lab.
Sure, thanks for the introduction and for having me today. So I always like to kind of describe myself as a climate-motivated water chemist, meaning that I go to locations where climate impacts are observable, and I look at the chemistry of water within that system to document what the current conditions are, and then to follow up and see how those conditions are changing through time with the impact of climate intensification. And then it also allows us to predict into the future how these systems might respond with additional climate amplification. So very much motivated by climate change, but my medium is water and looking at the chemistry of the water to investigate the impacts on any given system.
So when you're talking about your work, we said we were going to specifically talk about glaciers, but water, glaciers are mostly, I would assume, water, and climate change. So what spurred you to study this kind of concept?
Sure. Well, I've always been drawn to water. I grew up near a lake and always enjoyed being around water. And when I went to college, I gravitated toward the lack of access to water in different regions, just acknowledging that in certain locations, there's more water available than in others, and started thinking about, well, where does our water come from? Kind of diving into the hydrologic cycle, and a light bulb went off when I learned that the largest freshwater reservoir on our planet is actually ice in the form of glaciers and ice sheets. And so we think about water in terms of freshwater in terms of lakes and rivers, groundwater, but that's only a small fraction of the total freshwater that exists on our planet. The majority of it is really stored in these solid state ice formations. And as those reservoirs, the liquid water being held in the solid state, start to melt, we relocate where water is distributed on our planet. And some communities or locations depend on seasonal melt to recharge aquifers. Some locations are very far removed from ice, and so they don't have a direct implication there, but a lot of communities are reliant on snow water or snow melt and ice melt for recharge. And that really kind of drew me to investigating icy environments, where I started out interested in water, and then ice became this really attractive medium to investigate further. You could call me a glaciologist, and that's something that I also consider myself, but in reality, I study the liquid runoff that comes from these solid ice masses. So hydrology or water chemistry is really the motivation, even though I'm located near the ice.
So when you do your work, can you tell me in basic terms what problem, or I mean, you told us the concept of the water chemistry, but can you tell us what you're looking for and how you go about doing that?
Sure. So my lab group investigates quite a few different chemical parameters. In the most simple terms, we're interested in looking at what the water composition is from interacting with different mediums. And so one of the aspects that my group focuses on are nutrient availability and nutrient cycling within water chemistry and meltwater chemistry specifically, and how the nutrient compositions and quality changes through time with changes to an environmental system, which could include the temperatures increasing, the degradation or transition of plant types in the area, which contribute organic matter. It could do with the length of time that the water has to interact with its surroundings. And so water that is allowed to interact with rocks, minerals, organic matter in a system for a longer period of time will have higher concentrations than if water is flushed through a system more quickly and is not allowed that time to take on that composition and to interact and react with the surroundings. And so we can learn a lot about what changes are occurring in an environment based on the composition of the water chemistry. And I do have an analogy that I was hoping to share.
Yes, please.
I think it might be a good moment to share that right now.
Mm-hmm.
So something that I always use in my classes and in outreach activities is we can think about water in a natural environment, similarly to how we think about water in a glass, where if we have water that is in this closed system, the composition is very pure right now. But if we add something like a drink tablet, that as soon as we add it, it starts to interact with the water. And so the composition of our water is going to depend on whatever the composition was of anything it's interacting with. It'll also depend on the length of time that the water has to interact with the composition of whatever it's introduced to. And so if we took a sample right now, the composition of the water would be lower concentrations than it would be if we took a sample in, say, another minute when this completely dissolves. And so when we're in glacial environments or proglacial environments, the areas in front of the glaciers, changes to the chemistry can occur from changes to the length of time that water is interacting with its surroundings. It can also changes can occur from adding additional water to our system through more melt, which could dilute the water and make the concentrations less. But in addition, if we change the type of material that the water had to interact with and actually introduce different types of tablets, we would definitely have a different composition represented in our sample. So that's one way to just think about how water chemistry changes, is water takes on the composition of the materials that it's interacting with in some way. And so different types of materials interact more readily and can break down or dissolve into the system very quickly, while other types of materials might take much longer to have the signature show up into the liquid state. So we look at water compositions through time and try to interpret what might be causing the changes we see in the actual samples we observe.
Awesome. That was a great analogy. Thank you for sharing that. I think that would help us all better understand your work. So I know you said you've done a lot of different studies looking at the changes in water chemistry, and I would love to hear some of the outcomes you might have seen, or even if you're not done with your research yet, what you're looking for specifically that might help us better understand how water is being impacted by potential changes in the environment.
Absolutely. So in certain environments, we have ice that exists in the form of glaciers. And as we have warming temperatures, some of the ice is lost. And so the volume of ice in those environments decreases. In addition to the total volume diminishing, we also have the extent of ice coverage decreasing. And so if this is a slope and we have a glacier located on it, if we start to melt it away and it starts to shrink, we have the proglacial, or the environment in front of the glacier, become elongated. And so when you take away ice, you're actually exposing more land in some instances. And in the environments we look at, when you have the retreat of a glacier and the loss of ice mass, you have increased distance of a river system forming in front of that glacier. And so the actual change in the distance the water travels can have a large effect on the composition of the water as it's released from the system. So when we think back to the example I showed with the cup and the substrate we exposed it to, or the material we exposed the water to, if we allowed that water to have more time to interact, such as through increasing the distance that the water has to travel, some of those chemical reactions might reach equilibrium at different points along the distance that water travels. And that can actually cause additional reactions to start to occur that previously would not have occurred within that length, because the water did not have enough time to react to a point where it reached that stage. But if we increase the length that water has to travel, and increase the time that the water has to react before it makes its way from the glacier to the coast, because ultimately all water flows towards the oceans. If we increase that length, we can start to change the types of reactions that occur just by giving the water more time to react. And so some of my students have been focusing on the nutrient compositions in glacial meltwater. And so glaciers, as they melt, they release some organic matter. That organic matter can fertilize water environments and cause primary productivity or growth of organisms to increase. The composition of that organic matter can change pretty drastically if you, once upon a time, only had 5 kilometers to travel. The composition from the end of the glacier to the coast is pretty similar. It doesn't travel that far, not too much change is going to occur. But if you have the ice retreat dramatically away from that coast, and you now allow for the water to travel 10 kilometers before it reaches its end destination, there will be chemical cycling within that extra time and extra distance that changes what the composition is. And so to give a really quick summary of what that actually means is that if we have a glacier that's been contributing nutrients to a coastal system reliably, and all of a sudden we change the distance that the water needs to travel before it transfers those nutrients, we could actually end up with a very different composition or nutrient chemistry that makes it to the coast just by changing the pathway the water has to travel. And so the coastal system might not be fertilized as reliably anymore if we increase that distance. So that's a quick insight, or maybe it's a long-winded insight, but an insight of why we investigate meltwater chemistry and what impacts it could have on different systems.
So I'm going to kind of drill down a little bit more in terms of when we're thinking about impacting water systems, and particularly the coastal systems. When you have that extra growth that you were talking about with different organisms, what are the potential outcomes of having extra growth? Is there, I think of like, is it red algae that we see an increase in growth in lately, and what that might, how that might impact things? So can you give us a little bit of the, no pun intended, downstream effects of the work that you're doing, and how that glacial melt might be impacting? I'm here in Wilmington today, impacting Wrightsville Beach or somewhere
Absolutely.
else.
So the short answer is that we are definitely changing the composition of nutrients that make it all the way to the coast by changing the distance from the coast that the glaciers exist at. It's not always an increase in nutrients, so it might actually be a decrease in nutrient availability, or the type of nutrients that are most easily usable by organisms. And so depending on the scenario, if we have an increase in nutrient pulse from a glacial environment, you can overstimulate a coastal setting in terms of primary productivity, and you can have really dramatic and quick growth, population growths of algal species, which could actually deplete the oxygen of the system and lead to eutrophication and some fish kills. And so that's something that I am not a biologist myself, but I do study the chemistry that's needed to understand how biology will react. And so when we look at how the nutrients might vary in the future, we can say there will be less fertilization or less readily available nutrients making it all the way to the coast if glaciers retreat X kilometers. And that actually might lead to an under-fertilization where you don't get enough growth to support the upper food chain. And so depending on what environment you're in, there are some nuanced specifics to that environment that needs to be studied further. There isn't a direct, if this happens, the consequence is this, because there are so many nuances of each environmental or geographic location that need to be considered. And so having more studies that focus on specific systems will really help us predict and prepare for future change. And so some of my most recent studies have taken place out of South Central Alaska in the Anchorage area. And what we were looking at has implications for the fishing business in that region. And so anywhere from salmon spawning up into those rivers, or even making it out to the coast in the halibut that rely on the productivity of the food chain in that environment. And so just being able to track and predict what types of nutrient changes may exist will help us prepare for what does this mean in terms of sustainability of these systems? What does this mean in terms of being able to continue to rely on these populations for food or for industry, commercialization of economy, right? And so being able to have more insights to specific systems will help those communities prepare for the changes that could exist in the coming years.
And one of the things that I love that you just kind of mentioned is the idea that you don't work in a silo, you're not all alone, but that there are so many other types of researchers and community partners that work together to hopefully be able to identify and predict what might happen in the future. And then I would assume that someone else would take your information and potentially create intervention and prevention strategies that help to improve the sustainability of that environment. Is that correct?
Yeah, and so performing the actual research and getting the data is the first step. Well, it's a series of steps, but actually getting that data is really the first step.
A very important step.
Yes, you need it in order to be informed. But then to follow that up, you need to be able to communicate what you found to either the broader scientific community and find partnerships with people who do study the biology or the ecosystem health directly rather than just from a chemical perspective, or share that information further with community leaders, with stakeholders, with policymakers, and being able to communicate that work in an accessible and tangible way so that you're not over informing people to a point where it's confusing to figure out what the end message is, but to say, we know glaciers are retreating. We know with that retreat, we're changing the composition of the meltwater that is making its way from that glacial system to the end coastal environment. The changes in those chemistry will undoubtedly impact ecosystem health by manipulating the nutrient composition. And so if we have clear insights to how a specific system can behave or will behave, we can tell the people who are relevant within that location that these are the changes we will likely see. And again, it's human nature, I guess, to try to over extrapolate or to say what I'm learning in this environment is globally applied. And in some instances, it's true where we will see these changes in systems that are in front of glacial environments. But to say that what we're observing in Anchorage, Alaska is exactly what we're going to be observing in Scandinavia would be naive and probably not realistic. And so being able to have more insights to specific locations will better help inform people who are stakeholders or community members in those locations.
Yeah, and I think that's so fascinating, again, to be able to say, you know, there are going to be some aspects of your work that is generalizable across areas, but then also you are really serving these very important individual communities that the work that you're doing has tangible impacts on individual fishermen, for example, like what you were saying in Alaska. And I wonder, have you ever interacted with the local fishermen, women, fisher people, or is it more you giving information that is then translated to the industry?
That's a great question. And so I think that largely depends on the type of project I'm working on. And some projects were set up in a way where community involvement is kind of a keystone of that project, and being able to have that community inform you of their needs, so you can target your research to incorporate the output or the goal to fit within the needs, and then later follow up and share the results with that community and have it be authentic relationship where both parties are benefiting from that research. Or there's a more colonial approach of science where you go to a location, you get the data, you leave the location, you have the data, you write it up, and then you might not do as much community outreach in that instance. But I think there is a transition in the scientific community to have more authentic relationships built with communities when doing this type of work. And so the projects that I've started since coming to NC State, and even started before coming here, have had a higher emphasis on community involvement, both from the perspective of what is it that would be useful to know in these environments based on what you've been experiencing with climate change, or collecting some data and then figuring out ways that it can be accessibly communicated to communities, whether that's through a town hall. I've participated in many of those in Alaska, or whether it's through writing an article for the local newspaper that is very accessible in terms of, this is the work that has been done and this is what it means for this community. And I think the more impact, you will maximize the amount of impact you have based on how involved you are with the communities. And so it depends on what motivates you in your research. If you really would like there to be pieces of your work that have real world impacts, it's best to develop those relationships and make sure those relationships are authentic, and that the people that you're working with and the communities you're working with or working in really feel heard and seen, and are given access to the information that you're able to get from the work you do there.
So listening to you describe this, I do preschool education research, right? And intervention and observational work. And we use the term community engagement as a way to describe a type of research process. And then when we bring our students into the mix and have them working as well, that it becomes something like service learning, right? Where the students are working in a community to provide resources of some kind to the community, while the community is teaching the students about what it means to be involved in this type of work, and the students are reflecting on it. So I heard you say early on in this conversation that you said my students. So are your students graduate students or undergrads? What kind of teaching can you pull into this research? Because I think that would be really fascinating too.
Absolutely. So I have students that I interact with in a variety of ways, where I have members of my lab group who I have currently. There are 2 PhD students in my lab. We've graduated 2 master's students as well. And so from a grad perspective, we have early career scientists who are honing their skills, identifying what motivates them, and conducting research based on that motivation. And so I have students in the capacity of graduate members of my lab group, where we work together to answer these problems and build those skill sets. And then I also have had undergraduate researchers working in my lab group who've also started to answer some of these questions from a perspective of wanting to learn more about how science is conducted, how research is conducted, and answer the questions that we've been asking from much larger perspectives.
Mhm.
I also incorporate what I learned from my research into the classes I teach. So right now I'm teaching a course that's geochemistry of natural waters. And in that course, I use some of the data that we collect in our field campaigns to show the students who are enrolled in the course what real data looks like and what it means, and also that the fact that us faculty do more than just teach. We do research as well. And so to highlight that this is the type of work that NC State supports and that we are doing to further scientific discovery and to get really insightful information about these large questions we have about climate change and climate change impacts.
Mhm. So for those of you who are here live, if you have a question, please type it in the chat box, or you can even do a virtual raise of hands and I'll call on you. Otherwise, I'm just going to keep talking to Carly because I have so many questions. So, you know, there's so many cool things about your research, but I'd love to hear if you have like, this is the one or maybe two or three things that I thought, wow, recently or in the past, this is really the most interesting thing that I've found about my research. Does that make sense? Like what
Yes.
jazzes you right now?
Yes. What really jazzes me and motivates me is the ability to provide some insights to these natural systems that are changing. Above all else, I value being outdoors. I value my connection with nature. And I went into this career because I knew I could continue to connect with nature and to try to provide some knowledge where my skill set allows to better understand how nature is responding to changes that are occurring. And so I always get really excited when my students and I come up with questions that are currently gaps in the community, knowledge gaps in the community, and we're able to go into the field, we're able to go to these locations that are being threatened or are vulnerable to climate change, and we're able to collect samples, test our hypotheses, interpret the data, and gain knowledge about how fast things are changing, how they're changing in general, just what changes are occurring, and what does that mean in terms of ecosystem health? What does that mean in terms of future projections for how these systems will continue to change? And so for me, it's the scientific question followed by the answer, which connects back to just better understanding the natural world. And obviously nature will continue to exist without humans. It is bigger than we are, right? And so I think the human role of trying to understand it is something that allows us to respect it, and hopefully allows us to coexist with nature and not just take advantage of these resources of our planet.
So I've heard you talk about working in Alaska, and you've mentioned Scandinavia, but not necessarily that you've done work there. So my question is, North Carolina is not close to glaciers in general. So how do you go about doing your research when you're stationed in Raleigh?
Absolutely. So that's a great question. Obviously, in academia, you have an expertise. And then if you're lucky enough to make it to a stage where you're being considered for a faculty position, you're limited to what places are able to hire you. And obviously I was attracted to North Carolina State University, otherwise I wouldn't have been here. But the opportunities that arose from being employed at this institution allow me to go to these locations, collect samples, bring them back here so I can process those samples in my lab, interpret the data, work with students, do all of that from North Carolina, but having some connection to going and doing field work in these remote locations that are not directly accessible. So a lot of my work right now focuses on Alaska because that's part of the United States. And I think that is a location that is worthy of studying. It needs to be studied. There's a lot of change occurring there. And it's a place that I connect with. And so that's where a lot of my work has been recently. But prior to that, I've conducted work in Canada, Scandinavia, Antarctica, and Greenland. and we're hopefully going back to some of those locations. But right now I'm really motivated by what's happening in the United States and from the perspective of climate change in Alaska. And so North Carolina allows me to continue this research while being supported in this location by sharing this work with students who work with me here, whether they're my graduate students, undergraduate researchers, or in the classroom. And I think that's valuable, is to be able to gain perspective of locations other than where you are. And so myself having the experience and expertise in these locations, I'm able to share the importance of these locations that seem very far removed from us, but actually have really significant impacts on our quality of life in terms of sea level rise is something that's happening as a result of ice loss. We're experiencing that at the coast. The sustainable practices we have for our eating habits. A lot of the fish we eat comes from Alaska, such as some types of salmon, halibut, et cetera. But those types of things will be impacted. Even if we're not directly in those locations, we will experience the impacts of the loss of ice, even being removed.
Wow. Thank you so much. Carly, I have so many more questions I want to ask you, but we have run out of time and we're actually over time. And I thank you for giving me an extra minute or two here. So maybe I'll have to have you come back sometime if you would be open to it. So like I said, that is our time for today. And I do want to thank you, Dr. Arndt, for speaking with us about your research on glaciers and what you said, pro-glacial environments and climate change. And for all of y'all out there, I want to thank you for watching. And I want to remind you that we broadcast every third Friday of the month at 2 p.m. Next month, we'll include an interview with Dr. Vanessa Vlope from the Department of Psychology. She'll be talking about the Black Health Lab. So once again, thank you, Dr. Arndt. It has been my pleasure to talk with you, and there's just so much more we can discuss. So like I said, I hope you come back. So thank you all and have a good day.
Take care, everyone. Thank you.